Well, I got it all back together. I cleaned up all the brass and metal parts. Basically, it was all wire wheel work. There's quite a lot involved actually, and I'll bring you in closer so you can see what I've done. Obviously, the other repair that I did was to make sure that the flywheel is now fixed to the crankshaft, so when you turn the flywheel, the crankshaft turns without slipping, which is what it was doing before. So we'll come and have a look at it from the top. Yeah, it all went together quite well. It turns reasonably well and freely, and everything moves the way it should do now. All the rods go in and out properly, which is great. Now, I had to replace one of these little collars here. They're only bits of Meccano, so that was fairly easy. One of these was missing. But yeah, it's all gone back together quite well. I'll close in on it again for you. Needed quite a lot of cleaning. These rods, most of them were rusty. Obviously the brass was very badly tarnished. This is all now fixed down rigid, which it wasn't before. This is nice and rigid. So are the crossheads. They're nice and rigid. That's all great. The only area that still really needs attention are the bearing blocks for the crankshaft. Now, my good friend Rob over on the Zanudu channel, he made a comment on the first video I did on this, and he said it really looked like the person who built this didn't have access to any machine tools, and I completely agree with him. Having now had it all stripped down, I think this was all entirely handmade. Lots of filing, lots of riveting. So yeah, I don't even think he had access to a drill, not a pillar drill or anything. So yeah, I think this is entirely handmade. So the problem is there's a lot of play, as you can see, in the crankshaft, in the bearing blocks. Now, it's not surprising, it's a steel crankshaft in wooden bearing blocks. You're bound to get a lot of play. So what I may do is I may remake these bearing blocks out of brass, and that should give it a much better far less play in that whole area there. So yeah, that's a possible option, which I'm sort of seriously considering doing. Now we'll come back out again. At the moment, the top plate here is not actually screwed down. I can still lift this up, okay, because I wasn't sure whether I was finished with it. That will be probably one of the last things I'm going to do to it. So the next stage is possibly make some new bearing blocks for the crankshaft, and then look at some method of powering this so that I can get it to turn over slowly, and just as a demonstration model, really. But that's where we are with it at the moment. So I'm trying to think of a way of powering the triple expansion engine, and I was going through my box of electric motors and gearboxes, and I know you remember these. I did a video on this one. This is my lathe compound slide power feed, and this is the Sherline Mill X-axis power feed for the table. Now these motor gearbox combinations, they're brilliant little things. I mean, they're high torque motors. I think these are both 24 volts with the gearboxes, so you could get them in various different gear ratios. These ones for the lathe and the mill, they're 240 RPM, which is ideal with a variable speed controller for both the lathe and the mill. So anyway, I was going through my box of bits, my electric motors, and I found this. Yeah, it turns out I had another one. Now, I remember what happened with regard to this one. This was the first one I bought, and I didn't realise that on the Banggood page you could select the RPM. I just did the default one when I bought this, and this one is only 40 RPM, which is ideal. I wanted something that was runs really, really slowly for the triple expansion engine. So yeah, I've got to get that mounted in the other end of the base box, and I'll show you that in a minute. And there's various other things I've got to do, but yeah, this will be ideal for the triple expansion engine. Here's what I've done. I've just mounted the engineer gearbox. I drilled through the plate, the plywood that I put here, and mounted it on the side here. I've got to make up an extension for the shaft because obviously these have got quite a short shaft on it, but there is another hole here in the back Where's my pointy stick? There we go. Yeah. So there is another hole through here in the back, which will be ideal for mounting the switch. There's plenty of room to put a battery in there. So I think that will do the job nicely. Now, there was already 2 holes in the side here, and I've made use of this one, which is nice and central. Unfortunately, the fixing screws for the motor did break into this hole, but there's not really anything I can do about that. But that will do nicely. Now, what I've got to do is extend that shaft out so that it's out here, put a pulley on it to go up to the pulley at the other end. Yeah, so that worked out quite well. Like I said, the next job is to machine up an extension for the shaft, that's just a quick job on the lathe. While we're on the subject, quick workshop tip. I'm sure you guys all know about this. When you've got to make drill a pattern of holes to suit a mount like this motor. Yeah, there's various different ways you can do it. You can measure up the pitches and all the rest of it, but I found it much simpler to simply make a pattern up, which is what I did with this. A little bit of plywood, drilled a 19mm hole in it, which is the diameter of the boss that sticks proud around the shaft as it comes out the gearbox, and then simply put some marking glue, or in my case Sharpie, on the hole surrounds, which are proud anyway on the motor casing, and slide that over and press it against it, and you've got your whole pattern. Drill that out, and then I simply literally just stuck that on with a bit of tape on there and used it as a whole pattern, and you get all your holes in exactly the right place, and it's dead easy. So as I said, I'm sure you guys all know about this, but I thought might just mention it. So that's that bit done, and I've still got to work out what goes on at the actual crankshaft end. That needs a pulley, and I've got to get a shaft into there somehow, but you'll get this done first. Once I've done this and I've got the battery and switch in there, then I can actually get the top screwed down. So yeah, so that's where we are at the moment. Right, the batteries are installed, the motor's installed, the switch is installed, and we're pretty much all ready to go. So what this means now is I can actually fix down the top permanently to the base. Obviously it's held in place with wood screws, but I can access the batteries for charging by swinging this panel down, because if you remember, this is hinged at this end and it will swing down, so that allows me to get in there and charge the batteries when I need to. But no, it's all done, all works. I'll show you the motor turning. Now that pulley that I've got on there at the moment may not be the final pulley. I've still got to work out the pulley ratios and all the rest of it, but I've stuck the old lolly stick on just so you can see how slow 40 RPM actually is. So as you can see, it's not very fast at all, so possibly a 1-to-1 ratio would be fine. Maybe a little bit, slow it down a little bit maybe, but yeah, as I said, we're ready to put the top on. While it's all back together, this is the pulley arrangement I've got at the moment. This may change in the future. That's a Meccano, I think that's a 2-inch or 3-inch pulley. 3-inch, I think that one is. I ended up making a pulley for the drive motor out of one of my home cast aluminium pulley blanks, and that's turned out okay. At the moment it's slightly more than 1-to-1, so it's up geared a little bit, but this motor only does 40 RPM, and it's not fast enough. I thought it would be, but it's not. But we'll turn it on, and you can have a look. Yeah, it really needs to be turning over a little faster than that, I think. But I've ordered another motor which is quite a bit quicker, and I'll put a speed control on it so I can fine tune it to get it to how I want. I'll show you a top view so you can see it from the top. Now, as you know, I didn't really do much to this. I just basically cleaned it all up, but I had to do a lot of fiddling around to try and get everything to line up properly, so that it would turn reasonably freely. But the problem is there's an awful lot wrong with this. It really needs rebuilding, but I'm loath to do that because I truly believe that the guy who made this didn't have access to machine tools. Everything on here was done by hand. The riveting and the laminates for the rods and everything. So I really wanted to leave it as much as possible like it was when it was built, which I've done. But there are lots of things wrong. The conrods don't line up with the crank. The cranks aren't straight. The flywheel's not straight. Most of it's all bent, but it works. So, you know, this is where we are now. So the next stage though is to put a slightly faster motor on it, and then I will get I can fine-tune the speed, because this is really just too slow. But that's where we are at the moment. Okay, we've got the new motor and gearbox in there, and we now have this rather nice brass protrusion sticking out here. This, in fact, is the speed controller, or at least it will adjust the speed controller, so I can now set the speed. So let's have another look at it. So this was the kind of speed it was running at with the original motor, very, very slow, but we can now speed it up. Go the right way. Much better. Much better. And I can go fast, but obviously I don't want to go that fast with it, but too quick. That's better. I'll change the view so we can have a look overhead. Overhead view. I think this will about do it for the triple expansion engine. I don't really want to do any more restoration on it. Like I said, I want to keep it as original as possible, and all of these parts and the flywheel and everything are original. You can see the wobble on the flywheel, and as I said, that's due to the fact that the crankshaft is bent. The only real way to sort that out would be to take that all apart and make a new one. I don't really want to do that. So it works. You can see it working. And as I said, I think what's fascinating about this thing is the fact that I'm convinced it was hand built. Literally everything on here was handmade with hand tools, no machine tools. And that to me makes this a very, very interesting engine. So there you go, the triple expansion engine. It's been a long project. I'm trying to think when I started on this, probably over a month ago. You know, it's taken quite a lot of work, even though I haven't done that much restoration. It's just really been cleaning, but it has taken a lot of work, but it was well worth it. It was well worth it. Anyway, I hope you found it interesting. I certainly find this thing fascinating, and as always, thanks for watching. Cheers.